Wow, 3 parts. Must be your lucky day. So what happens if we don't have like a circle, like we have 2 lines here? We're still going to find the volume using cross sections, and we're perpendicular again to the x-axis, so that means we're going to be vertical. So remember, you're going to draw your shape. This is a line crosses here and here, and the other line crosses down, so it looks like this. There's our 2 lines. Our other constraint, x equals 0, that's just the y-axis. So we're looking at this region, this triangular region right here. So I want to find the area of that base. Remember, because to find volume, it's area of the base times the height. We need the base. That's what we're going to find right now. So I drop my rectangle. It's going to be vertical because we're perpendicular to the x-axis. So to get my base, if I draw, there's my rectangle. We know it's dx thick. And then to get the height, remember, we're going to take the top function minus the bottom function. So we get 1 minus x over 2 minus a negative 1 plus x over 2. And if you simplify that, we get 2 minus x. That's what we want. And if we wanted to find the area, like we did for area of a curve, we would just take this 2 minus x, multiply it by dx, and integrate that. But once we're here, the rest is actually not that bad to do. I want rectangles of a height 4. So what that means is, now my base, I'm going to raise up, I'm going to have rectangles. So kind of imagine that, kind of go through everything of a height of 4. It looks like a gigantic pizza or some very thick pizza. So rectangles of a height 4. So I draw my rectangle. It has a height of 4. It has a thickness dx, and the base of it is 2 minus x. So now when I want to find the volume, of this, what I'm going to do is I'm just going to kind of multiply them all together, because we know volume, length times width times height. That's how you find volume of a rectangle. I plug it all in. The length, let's say, is 2 minus x. The width, dx, the height is 4. And it's okay to write it that way. We just don't like it. We just like the dx on the other side. So I rewrite it, and I get 4 times 2 minus x dx. Commutative property in action. Now, now that's the volume of my one rectangle. To get all of my rectangles, I integrate it from 0 to 2. I go from 0 to 2 because of my domain right there, from 0 to 2. That's where my rectangles are going to go from 0 to 2. Now, what if we have a semi-ellipse? Well, that's easy. I draw a semi-ellipse right here. We know it has a height of 2, and so at the very middle, it has a height of 2. Now, from Algebra 2, we learned that this is called B. That's the distance from the center to the vertex is B, and the distance from the center to the horizontal vertex, we call that A. So they give me the formula for area of an ellipse, pi AB, or pi ab. I want to find what A is, so because I want to get the area of my function. I go pi, if I know what A is, by the way, it's going to be 1/2 because we're talking about a semi-ellipse. So I know the total distance down here is 2 minus x because that's my base. A then is just going to be half of that. And I plug it in. So 1/2 pi, remember 1/2 because it's a semi-ellipse, that's the area for a full ellipse. A, which is 1/2, 2 minus x, times b, which we know is 2. And I simplify that. 1/4 times 2 becomes 1/2 pi 2 minus x. Now that's the area of my semi-ellipse. To get the volume, I'm going to multiply that by dx, the thickness of it. So it's going to be 1/2 pi 2 minus x dx, and we're going to integrate that because that's one of them. Notice I put my pi over 2 on the outside. I integrate that from 0 to 2. And if you integrate this, you get a nice little answer. You get pi cubed. And the very last one, down here, we have a parabola. The base is bounded by a parabola, y equals x squared. So I draw that. Y equals 0, that's the x-axis, and x equals 2. There's my line here. But this time, we're perpendicular to the y-axis, which is weird, which is harder for us, because this is telling me that my line, my rectangle, has to now be horizontal. So when I draw my rectangle, this time it's going to be horizontal, which means we are now in terms of y. That makes it a little bit more complicated for us. So when I solve it, set it up, there's my rectangle. I'm going to get my base, dy thick. To go here, remember it's going to be the right minus the left. So it's going to be 2 minus the parabola. So the right's going to be 2. But to get the left, because remember, right, there's my right, there's my left. It's going to be 2 minus the parabola, but we got to be in terms of y, so we have to solve. Y equals x squared, x equals square root of y. Remember, it's really plus or minus, but we don't want the minus because we don't want the positive part. So 2 minus the square root of y, and that's how I get my area. So to get my area, I'm going to take this 2 minus the square root of y and multiply that by dy. But I want the volume. Well, to get the volume, we have to take a look at what shape. We're looking at a semicircle. So if I draw out my semicircle, the base down here we know is 2 minus square root of y. Well, to get the area of my semicircle, it's pi r squared, or 1/2 pi r squared. So you got to be careful. My radius is going to be half of that. So my area is going to be 1/2 pi times 1/2 pi, 2 minus the square root of y squared. Simplifying it, we get 1/4 times 1/2. I get 1/8 pi times 2 minus the square root of y squared. So that's the area of my base times the height, which we'll call dy, right? So my area, my base, 1/8 pi times 2 minus the square root of y squared times dy. And we integrate that. Be careful, from 0, we start at 0 because this is a point, 2, 0, and we go all the way up here to the point 2, 4. So we're in terms of y, so I'm going to go from 0 all the way to 4 because we're in terms of y. Alright, so that's part 3. Need any more help? Come on in or ask questions, not a problem. See you later. Bye-bye.